Today I'll discuss about the background of the wireless communications, different generations, and some wireless systems, existing wireless systems. The first question, what is wireless communication? It is basically transmission and reception of informations. Information means voice and data in open space using EM wave. That means there will be no physical communications or connections between a transmitter and a receiver. There will be no physical channels, means there will be no wired connections. The informations will be transmitted from a transmitter wirelessly, and it will be received at the receiver wirelessly. Now the second question would be, why wireless? The reasons are freedom of wires, that means there will be no burden of wires. Global coverage. Why global coverage? Because some remote places like mountains, sea, some hilly regions where the conventional wireless network won't be able to reach, but that wireless network can reach there. Stay connected while moving, which is almost impractical or impossible, if better I say, in case of wired communication. Flexibility is also there. Apart from all these 4 points, from the business point of view and personal reasons, that wireless communication became popular over the wired communications. Now, if we look at the generation-wise evolutions, it was started in 1980s. It was the first generations. During that time, it was only analog voice communication was there, and it was an analog communication. Later on, it was that digital communication started, and the second generations were evolved in 1990s. Along with the voice, a little bit SMS, small SMS, we were able to send during that time. Thereafter, in 2000, the 3G evolved. Along with this voice and low SMS data, internet and video calling were added. Thereafter, in 2009, fourth generation started with these existing facilities. Internet of applications were added, where online gaming and HD TV, those facilities we were availing. Now, if you look at the standard generations wise and the data rate, we'll come to know why the generations were evolved. During 2G, it was the standards were GSM and CDMA. During that time, the data rate was 10 kbps. During 2.5G, GPRS and Edge, data rate changed from 10 kbps to 50 kbps, then 200 kbps. GPRS basically developed on the same GSM platform, just the switching technique changed from circuit switch to packet switch. The facilities were voice and data only. Voice along with the low data rate. That data rate means low data rate. Only SMS could be sent. Thereafter, during 3G, 3.5G, the standards were WCDMA, UMTS, CDMA 2000s, and others are also there, HSDPA. The data rates were increased that from 200 kbps to 384, then 5 to 30 Mbps. Facilities were voice, data, and video calling. Thereafter, during 4G, the standards were LTE and WiMAX. Facilities, voice, data, video, online gaming plus HDTV, and the data rate was 100 to 200 Mbps. So if we look at the generations, apart from the voice, if we see carefully, only the demand of services due to the demand of services, the generations changed. Now, if we look at the growths year-wise from 1985 to 2000, the number of subscribers was in the order of millions. From 2005 to 2019, if we see, it is in the order of billions. In 2019, it was approximately 4 billions. It is in 2023, it was 16.1 billion. It is expected it would be 39.9 billion in 2033 at a rate of 10% CAGR, compound annual growth rate. Now we are in 5G. When the 5G started, what are the requirements? Need faster mobile internet, faster web browsing, download apps more quickly, streaming high quality video without buffering. Because if we look back 4G and beyond, if we want to download some videos or see some online matches, we experienced that after a certain time that it was downloading, then it again started the streaming again. After some times it was that there is that buffer, it was buffering. Okay, so we don't want all these kinds of hazards in 5G. That's what the aim of the 5G is, to connect or bring all the machines, objects and devices together. Thus there are 3 different categories. The first one is UMBB, enhanced mobile broadband. Second one is URLCC, that is ultra reliable low latency communications, and MMTC, that is machine type communications. All 3 categories for 5G new radio networks are used to enable various communications capabilities, and all 3 are working sub 6 GHz to some millimeter wave band. The goal of this EMBB is to take care of the speed, capacity and mobility even in the challenging conditions, whereas URLCC taking care of reliability in ultra level and low latency, and MMTC taking care of connectivity, means it will connect a number of devices with low energy consumptions. If we see the some use cases for 5G, for EMBB it is they are telemedicines, smart offices, events managements, public transportations, remote field surveillance. So all are already, these are well known to everybody, where these are taken care of by this EMBB. These are the use cases basically. URLCC, we see the use cases are factory automations, remote surgery, autonomous driver. Because if we think about autonomous driver, that even surgery case, the reliability and latency should be very critical factors. In both the cases, the surgeon, or that in case of surgery, the surgeon, or if the robot is doing the surgery, and in case of autonomous driving, that the car has to take decisions. So if there is any reliability is compromised or latency problem, then may be problem. And the use case of MMTC is smart agriculture, where a large number of sensors are deployed to monitor the various parameters like weather, soil moistures, and they are connected to a control center. They are communicating their data to the center. Accordingly, measures are taken. So this is basically a large number of devices are connected together. It's an example of MMTC. Now this 5G band is divided into 3 subbands. The low subband is less than 1 GHz. The mid subband is 1 to 6 GHz, and the high subband is 24 to 100 GHz. If we look, already we saw the first generation, fourth generation. If we see the first generation, it is basically massive broadband and IoT. There are some techniques to achieve the aims. Some techniques are, some are proposed, some are under research. So overall, they are millimeter wave communications, MIMO, that is multiple input, multiple output. These are already under use. Beamforming, NOMA still not under use. There is hardware complexity. Some problems are there because in NOMA, that is SIC, the cyclic interface cancellation is there. So there is hardware complexity is there. And mobile edge computing. These are some techniques which are proposed for 5G and advanced communications. If we look at the KPIs, means requirements, and for 5G and 6G, 5G were launched 1990 in USA, in India it is 2022. The requirement were higher system capacity, higher data rate, reduced latency, massive device connectivity, energy saving, and cost reductions. Whereas the 6G, it is expected it would be launched by 2030, but all these requirements, 5G requirements, are in ultra level, ultra high capacity, ultra high performance, ultra high precision, ultra high intelligence, ultra massive connectivity, ultra low energy and cost. If you look at the we can feel that what ultra level is. If you look at the KPIs numbers, In 5G, that maximum bandwidth it is 1 gigahertz, where it is for 6G it would be 100 gigahertz. Peak data rate for 5G it is 20 Gbps, for 6G it would be 1 Tbps. The spectral efficiency for 5G 3 times that of 4G, whereas in case of 6G it is 5 to 10 times of 5G. Latency for 5G it is 1 millisecond, for 6G it would be 10 to 100 microseconds. The energy efficiency for 5G it is 90% more than 4G. For 6G it would be 100% more than 5G. If we look at the mobility, in 5G it is 500 km per hour. For 6G it would be 1000 km per hour. Connection density for 5G it is 10 power 6 devices per kilometer square. For 6G it would be 10 power 7 devices per kilometer square. So we can see what is our expectations, what are the demands basically. That's what these KPIs are fixed. These KPIs are fixed basically based on the requirements. Now if I summarize in some words, in some lines, whatever I discussed till now about from 1G to 4G, if we see that development and the KPIs of 5G and KPIs of 6G, if we summarize, they are higher capacity, higher data rate, low end-to-end latency, massive device connectivity, reduced cost, and maintain QoS consistent. We cannot compromise QoS. Now we are at the end of the slides lectures. Now I'll just introduce, I'll briefly tell about some wireless systems. They are a paging system. You heard about it, it's almost obsolete. Still some places we are using this paging systems, like some emergency services, hospitals are there. Cordless telephones, cellular system. If we look at the paging system, that's one, that black one is given. It looks like this one. It operates at 400 megahertz basically. Mid 90s it was evolved, but that only few lines or few numbers we can send or transmit or receive, means we can send or we can receive. There is a paging center at the center of the city or some area. If you want to send a message like just given below, pick me from school, that kind of message, or yes, I reached to my home, don't worry, that one or two lines you can write and send to your friend or your relatives, or you can receive it. Another system, that is a cordless phone which operates at 90 megahertz, 1.9 gigahertz, 2.4 and 5.9 gigahertz band. In cordless there is a base unit which is wired connection, but from this base to this handheld device there is a wireless connection. Initially when it was started around 10 to 20 meters, later approximately indoor environment, that the distance between base unit and the handheld device, it was around 50 to 60 meters, and outdoor it could have, I think it was that it approximately 200 meter to 300 meter, that range. So now another system, that it is cellular system, where that entire geography is divided into small cells, each cells looks hexagon. Now the question here is why hexagon? I'll discuss why hexagon later on, next in the next lecture. Now just I'm discussing how the communication take place. At the each cell center there is a base station. You can see the cars. They are the, look at the cursor, they are the mobile users, mobile MS, mobile stations. If say this mobile stations wants to connect these mobile stations, obviously its information will, or call request reaches to the base transceiver system. From there MSC to again this base BTS base transceiver system, then this MS. This is how within a network it will work. Within under the same MSC it will work. If it is one MSC to another MSC, then this is the hierarchy. See, if any call is generated from this PSTN, it will hit to the first MSC, MSC to the BSC. MSC stands for mobile, PSTN stands for public switching telephone network, MSC mobile switching center, MSC to BSC base switching center, BTS base transceiver system, MS for mobile stations. Then any call generated from PSTN will first hit to the MSC, then MSC to BSC, BSC to BTS, BTS to the MS. There are two channels between BTS and MS. One is a forward channel, other is a reverse channel. Under one BTS there will be number of MS. Similarly, under one BSC there will be number of BTS. And same way, under one MSC there will be number of BSCs. So this is how a big region is covered by a MSC. So what are the challenges in wireless communications? If we see that basically that still we are experiencing when you travel through the train, or even the best experienced, if we go through the flight, we won't be able to use our mobile phones. So speed is a matter. High spectral efficiency. If we look at the TV bands, on an average these bands are not used properly, effectively. So there is a these bands are underutilized. So we have, spectrum is a natural resource, we have to use it efficiently. Zero ISI, global coverage, multimedia support, anywhere anytime, low power hardware, network support for user mobility, already talked, and quality of service. So these are the basically challenges in wireless communications. Thank you for today. Next lecture we will do cellular communications. Thank you.